Okay, so we're going to look at homework 2.4 real quick. I'm just going to do a couple of problems with you. So I'm going to jump in and look at this first problem, question 1. Okay, and you can see we've got these wing flaps per second for a sample of amethyst wood star hummingbirds. A bunch of different numbers here. Those need to be keyed into our calculators. So I'm going to just take a little moment here and do that real quick. Okay, so I'm going to start by resetting the memory on the calculator. You press on and clear together. Get a memory clear message. Then you're going to press data and just start entering the values. So I'll take that minute to do that real quick. So I had to put 4 80s in, just checking this real quick. So 1, 2, 3, need another one. Okay, and then 2 81s. 3 82s. Okay, 2 83s. Two 84s. Three 86s. An 88 and a 91. Okay, and then it's always a good idea just to check these. So I'm going to scan through them real quick. Okay, and these are all perfect. So once you get all the data in here, you just press the clear button. And then we do second data to do statistics. You want to choose one variable statistics on here, so you can press the direction pad to highlight that and press enter. And then you hit enter 3 times, boom, boom, boom. And then here are the statistics. So right now we just need, of course the sample size is 25, the sample mean is 81.52, and sample standard deviation here 4.04 something something, and we'll round that according to the instructions. Okay, so I've got all the computations done, so I'm going to go ahead and put in the numbers. So we're going to round these to one place more after the decimal than the data values. These data values have nothing after the decimal, so our statistics that we put in should have one place more, so that'll be 1 after the decimal. So the sample mean was 81.52, but I'm going to round that to 81.5. Okay, the standard deviation was 4.0426, but with one place after the decimal, I just have to go 4.0. Okay. And those should be good. Now the usual range here, I would take the mean and subtract 2 standard deviations. So on my calculator, I'm going to do 81.5 minus 2 times 4.0. So I'll just do that real quick. Okay, so that gives a 73.5. Okay, that should be all right. And then the upper limit, we do the same computation, but we'll add 2 standard deviations. So that's going to be 81.5 plus 2 times 4, and that comes out to be 89.5, like that. And then it says how many data values fell within the usual range. Well, again, it goes from 73.5 to 89.5. So the 74 is in that range, and the 89.5, I guess I can only go up to the 88 value. So there's 25 values altogether, but 24 of them are in the usual range. We'll just say 24 here. Okay, and that looks good. So let me see if it answers have not changed. Let's see if I can get this to scroll properly. Sometimes if you hold the cursor in a weird place, it doesn't scroll properly. Anyway, I think this one's done. Let me see if I can get all the, yeah, we got 5 out of 5 on that one. So we're good to go. On to the next question. Okay, so now we're going to do a problem with a larger data set. So this is my question 2. You'll get a problem like this, but it may not be question 2. Okay, so with the large data sets, we need to copy and paste these values into Desmos. Okay, so with Desmos, you can see you'll be typing A equals, and then in square brackets, you'll paste all of these numbers, and we don't want to copy the curly braces here. And then we'll just need the mean and the standard deviation with these 2 commands. Okay, so I'm going to go ahead and do the copy, and it looks like there's 100 values here. So I'm going to copy these. Okay, and then I'm going to launch Desmos. Okay, let me shrink this down to fit it into the window. And Desmos, we're not going to need to do any graphing yet, so I'll just go ahead and enter the command. So A equals square brace, and then a Control V to do a paste, and then you can close the square brace, and that should be a 100 element list. All we need is the mean of A and the standard deviation of A, STDEV for the standard deviation. Super easy. Now, these values have 1 place after the decimal, so both of these statistics will need 2. So we're going to do 63.36 for the mean. I'll go ahead and pop over there and do that. I think I said 63.36. Let me double check that. Yep, that's good. And then the standard deviation is going to be 4.23. So we'll pop back over here, do a check. Standard deviation is 4.23. Let me scroll that up a little bit and check. Looks good. Now the lower limit of the usual range, again, you will take the mean here, 63.36 minus 2 times the standard deviation, which is 4.23. So of course I have to do the computation on a calculator, so I'll do that real quick. So 63.36 minus 2 times 4.23 is equal to 54.90. Okay, that should be all right. And then the upper limit, you do the same computation, but you're going to add 2 standard deviations. So again, it's 63.36, but you'll do plus 2 times the standard deviation, which is 4.23. So I'll do that real quick on my calculator. Changing the minus sign to a plus sign is really all that's happening, and that comes out to be 71.82. Like that, and I'll check my answer. Looks good. And then once again, how many values are in the usual range? So it goes from 54.9 to 71.82. So 54.9 to 71.82, that's these values that I've highlighted. And so you'll notice there's 100 values altogether here, but 4 of them are outside of the usual range, so 96 are in the usual range. I'll go ahead and say, it says how many values? There were 96. Should be good. And the empirical rule says that when a data distribution is bell-shaped, it is roughly bell-shaped here. It's also called normal when it's bell-shaped. 95% of the values are within 2 standard deviations from the mean. So we'll give some small margin of error on this. Are 94 to 96% of the values within the usual range? Well, we got 96%. 96 out of 100 is 96%. So yes, it is true. That looks like a mistake. It says 93 to 97. That should be 94 to 96. A little typo. And then given your conclusion about the empirical rule, is this consistent with the assumption the values are sampled from a normal or bell-shaped population? Well, it looks bell-shaped. It satisfies the empirical rule. So I'm going to say yes, it is good to go. And let me double check here. I think we're done. So we can go on and I'll just look at my score here. I got 7 out of 7 on that question, so I'm done, and I can just go to the next question.